boutique consultancy out of Houston, Texas. We have a network of experts across all the verticals, medical, aerospace, industrial manufacturing, human factors, quality management systems. Our network is individuals typically, or privately owned employee-owned companies, with people that don't want to work in corporate jobs. So if there's anything that you guys need that you may think, oh, I don't know anybody to contact first, please reach out. We can solution anything typically, and there's a lot of domain expertise out there that we can tap into to help you out. So one of the main focuses of Radical Ingenuity Group is the industrial sector, and one of those tricky areas of the industrial sector is hazardous locations. Several names: potentially explosive atmospheres, HAZLO, classified areas. If you're involved, you know what we mean. People class it as intrinsically safe areas. Some misnomers, and that's down to a lack of fully understanding the risk. So today we're going to talk about one of those issues that really has confused the market. Several deviations seen recently, several LinkedIn chatters, major projects that have gone awry because of this exact issue. We're going to drill in today and clarify it all out for you. Hopefully it'll add some value to your HAZLOC experience and your projects. Getting this fixed at the start will save potentially millions of dollars. Hazardous locations. This is a type of equipment most people recognize. So when I say millions of dollars, I haven't dropped into hyper reality. I haven't dropped into clickbait, but I might put that as my title. It's a serious issue, and it's caused many problems over the last couple of years. What it is this international supply chains have got more diverse, more players, and new staff, new engineers, new FEED, EPC engineers that aren't really grasping the core knowledge requirements for this type of subject. So this is what a lot of people recognize from hazardous location equipment. These big bulky boxes, especially in North America, where explosion proof is a very popular methodology. This is a flame proof box. This is for the IEC and ATEX type scheme, and this actual device carries both ATEX and IECEx certification. What we're going to talk about today is the explosion proof subject related to this type of box. So this box actually carries a U certification. So what that is, it's been certified as a component. So when FEMA made this box, they certified it as a component in an assembly. So what that means is this box is designed to be brought into a system, an assembly, but part of the certification has been done. For a hazardous location system, ecosystem, there are a few parameters that we need to consider. Typically 4 baseline parameters to start off, to keep it simple. The first one is the likelihood of an explosive atmosphere around this box. So that is typically what we call a likelihood, and it comes in, those that know the zone scheme, it's typically a continuous gas cloud. A gas cloud is likely or unlikely, and the various schemes around the world have different versions of that. We won't go into that basic 101 today because I want to zoom in on something else. So the likelihood is factor 1. Factor 2 is the gas group. So this gas cloud that's around this box, what is some of its explosive properties? What is its ignition energy, and other factors relating to the gas, auto ignition temperature and the like. Auto ignition temperature comes into the third value, which is TClass. When I say auto ignition temperature, it's changed to ignition temperature in its terminology, but a lot of people like auto ignition because it makes sense. Ignition, it auto ignites at that temperature, which is different to flashpoint. And again, you know, we can go back to 101 with that as required. So we have those are the three main factors: likelihood, gas group, and temperature class. The fourth factor that gets skipped quite a lot is ambient temperature. So what is the ambient temperature of the environment around it? Because what that does is it creates an offset in the temperature class of the box. Because if this box is already at 40 degrees C in the Middle East versus somewhere in Canada, northern Canada or Alaska, the offset increase, there's an offset in the increase in temperature that basically compromises the temperature of this box. So there's sort of a derating goes on. Again, you know, we can go into that in more detail in another area. There's a bottom end to that as well. So ambient temperature is important at both the top end of temperature and the bottom. So normally, without any specifications like this one, it's minus 20 degrees centigrade to plus 40 degrees centigrade is the norm. So if you don't see an elevated ambient temperature on the data plate, that's all it's certified between. That's why it's really important when you're specifying a product is to have the fourth value of the ambient temperature in there. So if we drop to the three legs of the stool that are uber important: likelihood, gas group, and TClass. The temperature class is assessed as the system. It's an ecosystem of this box, if you like. So you have to know what's going inside, otherwise we cannot manage the temperature. The ignition temperature relates to the temperature of the external surfaces of the box and the internal. With this being an EXD box, flame-proof box, gas can get in, so it's a relevant surface to manage the temperature of. There's no seal in here, it's just metal to metal, so gas can freely flow in and out. And for anybody that knows the flame-proof concept, you know, that's a key part of it, is that the explosion can happen inside, but this box cools the flame so it doesn't get out into the outside area. So temperature class has to be assessed when everything's populated. So with this box being supplied by FEAM as a component, there is no temperature class assessment. It's not being done. Now, this applies to the North American market as well with an explosion-proof box. If it hasn't been tested as a system, there will not be a T-class on there. And that's the key difference between a classified box, like a U-box, and a listed system or an enclosure, because a listed means that the whole thing's been assessed. The key difference on the data plate is the temperature class will be missing on a component certified box. So we'll zoom in on this on the screen. You'll see that there's no T-class. So that is uber important for IEC and ATEX, because all the inspectors are looking for that. They're looking for the T-class. Now when it comes to North America, people are looking for an NRTL mark, whether it be FM, UL, CSA, MetLabs. There's 10 plus of the NRTLs now. So they're not typically looking for the normal form factor of the labelling. Now, the first thing that people realise is, in the scheme, there is a loophole where temperature class does not need to be marked on a North American piece of equipment if the temperature does not get above 100 degrees C. So people assume that that's the reason why it doesn't have a T-class on, but it's wrong. It means, if it says classified and no T-class, it means it hasn't been assessed as an assembly. It means it's just been assessed as a box. Now, let's have a think about this. So if I bought this as a marshalling box for some cabling, what's going to be the temperaturized calc inside? Well, we've got a barrier in here, so that would be a system. You're looking at the certifications on the barriers and looking at it as ignition risk as a system. Now, if there was just terminal blocks in there, what's the actual ignition temperature risk? The rise. So if gas was to get in, what would be the temperature on those terminal blocks in there? From a T-class perspective, we're not talking about ignition energies or anything else, we're talking about T-class. It would be nominal, if at all. So that's why people use classified boxes for marshalling that do not have a listing. As soon as you start getting componentry in there that's going to create different temperatures rises, when it's going to create pressure piling and the like, that's when we need to look at listings for North America. And the same with IECEx and ATEX, we need to move from a component certified box to a box that's been certified as an assembly. So on temperature class, you think, well, the ambient temperature is not going to be really that important, in the scheme of things, with all the temperatures around the world, different applications of these boxes, whether it be pharma, exploration, production, etc., petrochem. If we just take oil and gas, for instance, the ignition temperature of H2S is 232 degrees centigrade. So now 40 degrees centigrade as a starting point for your ambient now looks more interesting. So now that takes 232 degrees minus 40 ambient, so you're down to less than 200 degrees to play with within that box. So if you've got a hot component in there that's not been tested, in an enclosure like this, maybe a relay getting a bit hot, you only got to get to 200 degrees to ignite H2S. So that's why the offset is important. So let's take this off. Classified box, data plate, it's got a sticker inside saying it's been classified and it's ready to go for a system. Explosion proof box. So what has the manufacturer had to look at to get it to that stage, to get it to being classified? He's looked at impact, he's looked at explosion pressure of the empty enclosure. That's it. It's basically classified means empty box. So what do we look at when we do the system? So if we were going to list this as a box, with say with these barriers in or some relays or something like that, we've looked at the impact, we've looked at the explosion pressure for the final arrangements, and again, HAZLOC 101, there might be some pressure piling in there and things that need to be addressed. So that's a key part of it, is there's some tighter tolerances between the schemes on pressure piling and the like. There's maximum explosion pressure per arrangement, so an empty box would be different to a populated box with maximum explosion pressure. Again, this has not been tested for a classified box. Surface temperature inside and out. So when this thing's been fully populated and ready to go as a system, then the temperature rise is calculated. An empty box, you can't measure temperature rise. Arc ignition, so devices that spark in normal use are looked at as well as part of the system certification. For North America, one of the biggest things that catches people out again is the ordinary location approvals. So we have hazardous location and ordinary location. Ordinary location is mandatory in North America. It's the risk of shock and the risk of electrical fire. So those things have to be assessed, and that as a listed component, listed assembly, has been checked. Classified, it hasn't. Threading compliance and labeling requirements, all of that, when you see the listings, has been checked. Classified, it has not. So when you're going on doing your inspections, when you got a classified box, an extra level of diligence has to kick in as an inspector or an engineer. And now we get to the tricky part. So legislatively, or legally, if you like, people like to say, what are the requirements? So the European schemes, the international schemes, are very prescriptive. Pass, fail, go, no go. Check sheets involved, all the rest of it has been developed, been used for many, many years, all of my career, and there's a pass, fail, and the inspectors know where they stand, or the engineers, or the designers, or anybody else. With North American type compliance, there are actually 3 ways of getting approval which catches people out. So there is a listing or labelling by an NRTL, which is the number one, which everybody knows about, UL, CSA, etc. There is testing by a recognised lab that is suitable for the authority that's looking after the facility. And then there's full approval by authority having jurisdiction, which authority having jurisdiction is the person that is in charge of the technical compliance of a facility. And it can be anyone from a local fire marshal in California to an owner-operator that self-insures themselves. So that's where the real confusion starts to kick in. Typically, large-scale projects follow the rules. They're looking for the listings, labelings, and probably more than the minimum compliance levels. Everybody shoots for minimum compliance levels when the key thing to shoot for is what your customer needs. So with something like this, that's when the arguments start, is who's the EHJ? Did he say this was, or did he or she say that this was the right thing to do, or did they pass some approvals? Which is all well and good, and that's been the North American legislative framework for ages, and it's regulated by OSHA. OSHA don't go out and proactively audit these things. It's industry-led, and typically, it gets sorted in the courtroom. Now, if we jump to oil and gas, we tend to follow API requirements. And with hazardous locations, a lot of the oil and gas facilities, whether they're offshore, onshore, floating modules, whatever, like to follow API RP 14, which is the recommended practices for hazardous location installations. Now, I've seen it for land rigs, so when people say it only applies to certain industries, it's whatever the customer wants. So API RP 14F is for class and division type installations, and API 14FZ is for, or FZ, if you're from where I come from, is for the American zone installations. Now, you can argue that TClass doesn't need to be marked or whatever diligence has been done, but those codes specifically say that TClass must be marked. So if you were going to the letter of that code and there's no temperature class on there, even though it's below 100 degrees C, etc., it's in non-conformance in the black and white clause by clause review of that API recommended practice. So what API are wanting you to do in the letter, in the wording of the recommended practices, employ the system by the listing organisation. So that's pretty self-explanatory. Is they would like you to follow the NRTL rules, which basically is pointing you towards listing, but the NRTLs are not in a position to guide you on what you should be installing where, because that would be a conflict of interest. So what API want you to do is follow the system employed by the listing organisation. So that would be your nationally recognised testing laboratory, NRTL. Ironically, the NRTLs, for the rules of impartiality, are not allowed to guide you on installation or technical compliance for your projects. So that is a bit of a discussion point, and that's where grey-headed consultants come in. So there are major multi-billion dollar projects in executed, that have missed all these points about classified equipment. And you have to ask the reason, why is that? Well, we all know the lack of domain expertise now in industry. It's leaving, gone, not coming back, etc. So these gaps appear for that reason. Now, the EHJ, or the approval body, is what people shoot for when the minimum requirements. Again, we shouldn't be shooting for minimum requirements, we should be shooting for customer requirements. Well, when it gets to the audit stage of a multifaceted project, it's a very zoomed out level. So, you know, you're looking at a facility, you're doing a ship classification, you know, from the likes of ABS, Lloyd's Registered, BV, etc. They do not zoom in to the point of looking at internal components of boxes. It's just not feasible with the timescales and their deliverables. So by the time that stage, that's right at the end of the project. Where this should be tackled is right at the front of the project, when equipment has been specified, is being received, and when it first goes in. And we call that the technical compliance resolution. We can zoom really close in to all the details on this box when it's been taken out of its cardboard box or its shipping container and installed and the data's been collected. When it gets to the point where you've got a platform in front of you that needs looked at, you're not going to pick up on that level of deviation. And you know, when you pick it up at ship class, it's a multi-million-dollar issue if you haven't done it right. And that's what I was alluding to before, is we can save a considerable amount of money with upfront due diligence on the technical compliance requirements for a project. I've been involved in a project where the final sign-off, the ship class agent, if you like, has said that as long as the box is certified by, or classified, was what they're saying, by an NRTL, it doesn't matter what's inside. And there's been various letters, Coast Guard letters, things that have been developed for different scenarios have been leveraged to say that that's the truth. Well, if you go back to the original point is, if you don't know the temperature class of that box and in an H2S environment and the gas gets into that box inside and you don't know what's in it, you are not managing your explosive atmosphere. So there's projects out there that are struggling because the Ship Class Society has said that it doesn't matter what's inside a box as long as the box is certified. And when I say certified, it's their term, certified, i.e. classified. And, you know, there's differences. There are different marks for different schemes. There's a recognised logo as well for a recognised component. Again, it's not the individual prescriptive nature of the items that's important. It's the assessment of the assembly at the end. And you know, some agencies are more difficult to deal with than others. Some require that all safety critical devices are certified by themselves. Some agencies accept data from other agencies on those items. And again, it's a minefield that with a bit of guidance it can be navigated quite successfully and value engineered. So who's losing out here? It's the end users. The end users are losing the control of technical compliance because the supply chain doesn't really understand the requirements. The supply chain is really underskilled at the moment with the types of inspections required for North America. And there's some big projects coming up. LNG, offshore, production, drilling, land, etc. This issue is a long-standing one. Again, you know, it only comes to light when something goes wrong. So, you know, 99% of the time, it's not a problem because it doesn't get detected. And when I say not a problem, I mean people get paid, the projects get delivered, etc. But that inherent risk is sitting there waiting for that spot in time when the process safety Swiss cheese drops so all the holes align, and you know, a number of control measures are missing in that process safety model here. As we went through the testing requirements for an assembly, are several layers of that Swiss cheese that are missing. There are other API recommended practices that that do link back to NRTL listings and ask the question, and those can all be driven out as required on request. Risk management document for facilities mentions it, NRTL listing, etc. So all the legislative framework exists, and the reason for that is because an API recommended practice is just that. It's a recommended practice. An API standard is a standard that it should adopt, but again, the only way that these things become a legal vehicle is when they are incorporated by reference into the Code of Federal Regulation, whether that be for the Coast Guard, land, fixed platforms, etc. Well, a number of the API recommended practices are incorporated by reference, so therefore are a legal mandatory document. Two offshore regulators, US Coast Guard and BSEE for the Gulf of Mexico, the ones that deal with North American compliance methodologies, actually have a checklist, and it goes through a number of the API recommended practices as what a BSEE inspector would look for, and Bureau of Safety and Environmental inspectors are, they're looking at fixed platforms, particularly US Coast Guard looks at floating, but there's a lot of collaboration learning and coaching between the two agencies, so when one finds something, the other soon picks up on it. To summarise the subject matter in discussion is the catch-all everybody uses is this requirement for anything under 100 degrees C for North America not to be marked with TClass. That only applies to listed assemblies, devices, etc. It does not apply to classified devices. So if it says classified and no TClass, it means that that system has never had any assessment to calculate the temperature rise with what's in front of you. So you imagine that device could exceed the ignition temperature of the gas cloud that potentially is in that area, and therefore it is an unmanaged ignition source that a lot of people are signing off and approving to say that it's okay because even though the TClass isn't there, it doesn't matter, and it's just not true. If you have any more questions on this type of technical challenge to capital projects or minor projects, please feel to reach out to me. I run a consultancy that specialises in this area, and we have several experts across hazardous locations, from product design, installation, commissioning, running, inspections, and the rest, and ordinary location as well. So it's a true one-stop shop to help you manage all your ignition risk management for your facilities. Radical Ingenuity Group. So Radical Ingenuity Group has hundreds of years of experience working in automation, industrial environments. Personally, I've worked over 35 years on and off in the HAZLOC industry. My first job at 16 years old was at IECEx Wilton, northeast of England, one of the largest chemical sites in Europe at the time. And we used to do flame-proof inspections all the way back then with check sheets. So nothing new here. The codes and standards change over the years a little bit. But if there's any educational requirements that you need, whether it be remote learning, LMS, face-to-face, etc., just reach out and let us know. We're ready to support, and we'll make it easy for you. We have a high pass rate, which typically a number of providers don't have in this space. That's it from the Radical Ingenuity Training Centre today. If there's anything that you need to know about any subject matter that you think that we should cover, whether it be from any sector, whether it be industrial, medical, human factors, quality management systems, we have domain expertise across all areas. This is a network of individuals, of employee-owned companies and the like that don't want to work for corporate entities, so we can get you that boutique service, like stellar customer experience. Thanks again for watching. Please like, subscribe and share as appropriate, and look forward to seeing you next time. Thanks.